Hello students. Today I talk about separable of differential equation. Separable form have variable, so you should separate these variables respectively and apply the integral on both sides considering integral constant. I prepared modified college board problems and I hope it is helpful for you to prepare AP exam BC. Let's solve these problems with me.
Okay, let's problem the modified college board problems. Before solving the problem, let's check this concept. Separable. A differential equation has variable separable. If it is of this form, dy over dx, fx over gy, you should separate variables respectively. So dy move gy equal fx dx and integral on both sides gy dy integral fx dx plus c. By using this step, let's problem number 2. Okay. If dy over dx equals 3 times y, and if y equals 3 when x equals 0, then you should find this function y. To solve this problem, you should separate variables respectively like this. This is dy over dx, 3 times y. Move this 1 over 3 times y dy equal dx. Integral on both sides. This is 1 over 3 times y dy integral dx. Extract this fraction 1 over y dy. This is dx. Okay. This part is 1 over 3 ln y. This is x plus c. Multiply 3 on both sides. 3 times x plus 3 times c. Y equal e to the power of 3 times x plus 3 times c. Separate these e to the power 3 times x, e to the power of 3 times c. You can write just c because this is constant and is undecided. So y equals c times e to the power of 3 times x. Okay. Yeah. To find this constant, you should plug in this value instead of x and y. X equals 0, y equals 3. Plug in this value 3, c times e to the power of 0. This is 1, c equals 3. Plug in this value again, y equals 3 times e to the power of 3 times x. So the answer is A. Okay. Next problem is 11. I uploaded this material in my homepage. Check the description and download this material if you need. Okay. Okay. Which of the following the solution to the differential equation like this for y is more than 3 with the initial condition x equal 1, then y equal 5. Okay, follow the steps about the differential equation. You should separate these values respectively like this. dy over dx equal x minus 1 times y minus 3. Separate like this, y minus 3 dy. This is x minus 1 dx. Okay. Apply the integral on both sides. Integral 1 over y minus 3 dy. Integral x minus 1 dx. This part is ln y minus 3 because take it this to explain in detail. Integral 1 over 3 dy. You should use the substitution integral. Follow 3 steps. T equal y minus 3. To change this dy into dt, differentiate this equation on both sides, dt equal dy. This part is this. This part is this. So you can rewrite integral. This is 1 over t. This is dt. So this is simple. This is ln t plus c. Plug in original value. So ln y minus 3 plus c. So this part is c. This part is x squared minus x plus c. c1, c2. Okay. Even if these constant subtracted constant, it is just c because this constant is undecided. So ln y minus 3 equal x squared minus x, just c. So this is y minus 3 equal e to the power of x squared minus x plus c. I can rewrite like this. Yeah. Oh, this is just c. Okay. So y minus 3 equal c times e to the power of x squared minus x. Y equal c times e to the power of x squared minus x plus 3. To find this constant c, you should use this initial point x equal 1. X equal 1, y equal 5. Plug in this value in this equation. 5 equals c times e to the power of 1 minus 1 plus 3. 5 equals c times e to the power of 0 plus 3. 5 equals c plus 3, c equal 2. Oh, plug in this value again in this equation. Then my goal, the answer is y equals e times e to the power of x squared minus x plus 3. So this is answer. The answer is B. Okay. Which of the following is the solution to the differential equation dy over dx equals 3 times y over 3 times x plus 1 with the initial condition x equals 0, y equals e. For x is more than minus 1 over 3, okay. dy over dx equals 3 times y over 3 times x plus 1. Let's separate these variables respectively like this. 1 over 3 times y dy, 1 over 3 times x plus 1 dx. Okay. Apply integral on both sides. 1 over 3 times y dy, 1 over 3 times x plus 1 dx. Extract this fraction. This is dy. Integral 1 over 3 times x plus 1 dx. The left-hand side is 1 over 3 ln y. The right-hand side, take this. This is. Let's utilize the substitution integral. Follow the three-step first. T equals 3 times x plus 1 to find dt. Differentiate on both sides. Dt equals 3 times dx. dx equals 1 over 3 dt. Okay, plug in this value instead of dx. Plug in this instead of 3 times x plus 1. So I can rewrite this is 1 over t, 1 over 3 dt. 1 over 3 integral 1 over t dt. This is 1 over 3 ln t plus c. Plug in this original value 1 over 3 ln 3 times x plus 1 plus c. So c1, okay. Actually, there exists c1, c2. This is 1 over 3 ln 3 times x plus 1 c1. If you subtract this constant, the result is another constant. So you just write just c. 1 over 3 ln y. This is 1 over 3 ln 3 times. We should consider positive part. So 3 times x plus 1. This is just c. So multiply 3 on both sides. So this is ln y. This is ln 3 times x plus 1 plus 3 times c. So y equal e to the power of ln 3 times x plus 1, 3 times c. Yeah, just c. Yeah, because it is not fixed. In other words, it is undecided. So y equal e ln 3 times x plus 1 e times e to the power of c. Oh, it is just c. And exchange this two parts. ln's property. By ln's property, y equal 3 times x plus 1. This is c. To find this constant, let's use this initial point, x equals 0, y equals e. Plug in this value, this equation, e, this is just c. Oh, c equals e. So the answer is y equals e times 3 times x plus 1. So the answer is B. Okay. Okay, final problem, this 18. Yeah, this. To find FE, first I try to access fx by using this. So to utilize separable, I can rewrite dy over dx equal to 3 over x. Okay. Separate these variables respectively. So dy over dx equal 3 over x is dy 3 1 over x dx. Okay, there is no y. Apply integral on both sides like this. This part is y plus c1. This part is 3 times ln x plus c2. If you subtract these two constants, then just c. So y equals 3 times ln x plus c. Yeah. To find this constant, let's utilize this initial point. This is 3 times ln cubic e plus c. Okay, this is all down this exponential. 3 equals 3 times 1 over 3 plus c. So this is 1, c equals 2. So plug in this value, this equation, y equals 3 times ln x plus 2. This is my purpose. This is fx 3 times ln x plus 2. So f equals 3 times ln e plus e. So fe equals 5. So the answer is D. These problems are modified of the College Board problem BC. So to improve the separate part, I recommend you should these problems. Thank you for listening.